I'm late. Actually, I'm Peter Murray. We're going to have a talk about the second bad jokes in the second half of a presentation I did on Monday, which was called Getting It Right and Method and Implementation. No, today is the implementation. The first one was the methodology, and we talked about the importance of testing the way an application is going to run in a data center. So elements of that were making sure you get your I/O patterns right, that you use the data content that reflects the type of application that's running there, that you have something called temporal and spatial locality. In other words, that you lay down, you write data and read it back in ways that the application really does with variation. It's not just a flat line. And data content, temporal, spatial locality. And with the most important thing, with bursts. How many people use VD Bench for testing? Do you have bursts turned on? Do you know if they work?
Probably not. I doubt they do. Like what you were talking about the other day.
Yeah, well, I'll touch on that today. So it's important to do that because you want to.
I know FIO does.
No.
I use that as well.
That's straight I/O. And also I'll talk, the reason why those elements are important is you want to emulate an application as closely as possible. And you're going to have one of the biggest elements of that is how the data arrives at a storage array. And data doesn't arrive in a nice, even flow. It bursts all the time. And when that happens, queues can back up, CPUs can get overrun, well, not overrun, but very busy, and it can slow traffic. In fact, that was a problem that we had early on. We wrote this great storage testing tool, and we went out and people say, well, you're slower than VD Bench, get out of here. And it took us a while to really work with them to help them to understand that the reason for that is we were actually operating in a more realistic way than the freeware shareware tools were. So I talked about that on Monday, and you can get a copy of that presentation if you're interested. Today I'm going to talk about how we do this. And let me admit up front, this is proprietary. We sell a load balance, sorry, what am I saying? We're selling I'm going to step back and say, I want to say the best damn load generator on the planet. I'm not supposed to say that, right? Because it's, yeah. But anyway, we sell a load generator, multi-ports up to 8 16 gig Ethernet, 10 gig Ethernet ports, 16 gig fiber channel ports. Hang on there, Sparky. We now have, those 8 ports of those, or you can get up to 4 32 gig fiber channel or 4 40 gig Ethernet ports now too. So we can really slam an array. And up until last year, there wasn't an array I had seen where we were unable to essentially flatten it with a single storage appliance that we have. It's very high powered. So today I'm going to talk more about how we implement all of that. And here we go. I hope I got all my mush mouth out in the first 2 minutes there.
What is the name of your product?
The company is named Virtual Instruments. The product itself is named Load Dynamix. In the past it was named Swift Test, and most people know it as the Swift Box. I don't know. I'm not in marketing, and I didn't want to change any of those names, but those happen. So people know us back from, our first shipment was in 2009. We've been shipping since then. We started out as just a file tester, SMB and NFS. We've expanded beyond that to iSCSI, to fiber channel, and we've now expanded into object storage as well. So there's a lot of options for that solution. But I want to talk today really more about the methodology or the implementation of how we do the testing. I've talked about what should be in the test. Now I'm going to talk more about how we do that. So some of the questions that we run into. Why do people bother with storage testing in the first place? Well, it's a different answer if it's a vendor than it is if it's an enterprise, but it's important to both. So what's the best technology for my needs? Well, that's typically an enterprise is going to ask that kind of thing. Well, do I buy a tiered system? Do I stay with drives? Do I buy all flash? Am I going to go to NVMe? All of those questions are important to understand. So which is the best vendor or product? Find out by testing. What is the optimal config? After you've decided on the technology and the vendor, it's important to configure that product so it's going to work well. Setting up your queue depths. How many ports do you need? How large do you really need to make it to size it for your application? Want to know whether performance degrades when you start doing the extra stuff that most people don't test for in the first place. Snapshots, backups, replications, sometimes the end of month processing, end of quarter processing, where you have a very different traffic pattern going across the array. So we want to test under those conditions as much as we can. So performance limits of a particular configuration, exactly. You're trying to size it so you get what you need and not too much. Vendors tend to over-provision, but the problem is, especially, it's maybe less today, but with drives, oftentimes we would see implementations where at the end of the lease, there's 3 to 5 year lease, they're turning everything back in and getting a new array in at that time, and they'd only used half the capacity. So the rest of it was just burning electricity or taking up rack space, wasn't doing a lot of work. So what happens to the array if it reaches its performance limit? Does it fall over a cliff? Does it degrade gracefully? We want to understand this. And the bottom line for all of this is typically latency. When does my latency start to spike up? In the testing business, we have something that we call the knee of death. And it's usually when you hit capacity and we just keep trying to feed the same load in and we see sessions dropping or latency goes up really high and really quickly. You won't see that typically in a data center, although we did have a customer that had a 5-node scale out, and they got up to added the 4th node, and the whole thing fell over. So those things happen. You want to test up until your expected capacity and requirements, and then a little bit beyond that, just for the sake of being careful. How does performance degrade over time? Does preconditioning failing to precondition long enough, or does garbage collection come back and bite you later on, depending on the array that you get and the performance out of it? Let's see. Oh yeah, not only for testing for bake-offs. Most of what I was talking about here was what you're doing to try to find out what's going to happen in maximum performance, how it's going to go. But also, with a new firmware version, do you get a regression? When you've got even a switch or another component in the network, what happens when you run that same load at that? Now, we're not going to try to recreate an entire data center, but we can take a subset of that in a lab and recreate and get a reasonable idea of what's going to happen. Lastly, so that was it. I got them all. And if you do these, an upgrade, does it change anything else besides just your daily operation? So the traditional approaches I will talk about for a minute because we've been doing things like this for a very long time. Find the limits, do functional testing, inject errors, do soak testing just to see that it's going to run before it goes into a data center. So we have 2 methodologies, workload modeling and, come on. Oh, it's not going to display it. Here, let me go. I guess I got ahead of my, yeah, there we go. Performance polling. And I'm going to talk profiling. I'm going to talk about performance profiling first. This is traditionally how people test. Like I said, let's find limits. Let's do a lot of iterations, things like that. It's valuable testing primarily for the vendors rather than for the enterprises. Hopefully those types of issues have already been ironed out before the product gets in front of an enterprise. So for those, now I will say there's some large enterprises that still test this way, but it doesn't really tell you how your application is going to run in your data center. But we'll start with that. So we want to characterize things under a wide range of workload conditions. Just performance conditions. I don't like workload there because it's not really a workload that we're testing. We want to understand the sweet spots, the weaknesses of an array, block sizes, I/O rates, things like that. Sometimes we call this four corners limits testing. We offer the capability of doing a bit more than that. Sorry, there's a little bit of markety stuff in here. So vendors use this all the time to find out limits of their arrays. The IT customers don't generally get as much benefit. There's always benefit from testing. But a lot of this limits testing, what hadn't even been done in the past by the enterprises, because they simply didn't have the time. Setting up VD bench tests and reiterating, iterating takes a lot of time. And you want to make sure when you're doing that, you can't interrupt and go away and come back, because if that test stand changes, some new systems get put in, driver levels change, applications, anything running, if any of that changes, it's a new test. You're not going back to that same test. You may get some comparable ideas, but it's really important to try to keep that test bed stable. So, performance profiling, this is an example from the application that we run. And what we do is we'll set up a basic test that's going to do some level of I/O, and in here then we can come back and change things like access patterns, request sizes. You'll see these are all constant, so it'll all be 4K, then all 8K and such. QDEPs, this one, we're finding very interesting things. A lot of vendors are saying increase your QDEPs. We're finding that, in fact, performance of applications tend to improve with lower QDEPs. It seems kind of counterintuitive, but that's what we're finding in the world. Throughput, we can check at different rates. We can check data reduction. That's deduplication and compression. We have a method for generating random data or compressible data at near line rate. So we can generate huge amounts of unique data or combinations to make it dedupable and to provide varying compression levels. So this is a really easy way to do a lot of those tests. I talked about having to set up a lot of VD bench tests. This can be configured in about 5 minutes, and it can run for weeks. We had, the first time we sent it out, we had a very, I don't want to say aggressive, optimistic customer who was starting to run tests, and we had a database that we thought was sized for him. He managed to stuff the database in 2 weeks. Thousands of tests because he was able to go through and do these iterations. Well, now if you do iterations for a longer period of time, you might find more interesting things. So there's 2 ways of looking at that. And from this, the results we get after the tests we can sort on different of the headers, so you can find what access pattern gave you the best performance, what block size, QDEPs, whatever it might be of interest, and sort along those. Okay, so that was performance corners testing, because that's what everybody's pretty much familiar with. We've got a different model that we use now, and that's what I want to talk about the rest of the day. So we have this workload modeling application. It's called Load Dynamix Enterprise. It's a web-based GUI that allows fairly simple configuration. For those vendors who want to do specific command sequences and long sequences and test corner conditions and test parameters within a command and all that, we have a second, we call it programmer's interface, a second application that does that. So even those complex tests could be loaded back into this simpler web-based GUI, and tests can be run that way. So we can go back and forth with those. So we have the workload modeling application, Load Dynamix Enterprise, or TDE as we call it, Test Development Environment. And we combine that with a purpose-based load generation appliance. And we have probes as well from the other half of our company. Load Dynamix merged with a company named Virtual Instruments, who does who does data center modeling. And by taking taps, there's multiple ways of doing it. We can do it by software to talk to arrays and switches and VMs and things like that. Or we can also monitor from the wire and pick up wire data, which will give us the most accurate view of what's going on. Those combined allowed us to profile what's going on. We can also take information from other means that I'll show you in just a minute. But out of this, we characterize the performance of a particular application over time. Now, an application doesn't look like an application even 20 minutes apart, but there are typical patterns that you'll see during a given time period. You can create a profile for an application during that time period, and then add those in. We have the capability of doing that, so you can run daily operation. You can show it in the presence of backups. You can show it in the presence of somebody doing snapshots and clones. You can also do it with the periodic processing, the different things that happen during the business cycle, and test those together to see what the effect is going to be on the array. So, one thing that we found when we were out selling early on, vendors want the application workload. They want the Oracle workload. Enterprises want their Oracle workload. And I will assert that workloads are like fingerprints. They're not like each other. And they can be vastly different. They can be vastly different at different times of the business cycle. So before you even go into test, it's important to go in and kind of profile and get a baseline of when the busy periods are, when the tough periods are, and we use those to do the modeling. And you don't want to just willy-nilly go out and grab when was the busiest time for everything that was happening, because those aren't likely to overlap. But think clearly about what you want to do to make it so that when you are testing, you're going to hit that array at the hardest it's probably going to be used for that application, so that you can make a better choice. And especially with flash arrays now, given that applications are being aggregated onto a single array, it's important to think about the different parts of the business cycle and the use cycle for those different applications. But those can also be combined together to help you understand maximum what you think you're going to get today or need today. And then 4 to 5 years in the future, we can just take each of those workloads and crank them up to a higher rate, so you can get a view of how they'll work in the future as well. So vendors all the time want to find realistic array and scaling limits for their arrays. They want to see issues, customer issues. So for example, we could get performance stats from a particular vendor's implementation at a customer, bring that back in and run that test against an array back at the factory. The IT customers, I just want to make better decisions. Help me not spend so much. Make sure that what I buy is going to work. We regularly see that provisioning is pretty far in excess of actual need over the expected life of an array. It can be 40% or more, depending on that customer and their tolerance for risk and their budget as well, of course. So we've seen situations where we've gone out and helped a customer test where they had been specified a large number of nodes, for example, and we were able to prove that particular application was going to need no more than half of that. So we add a couple more nodes in there, and now that application is sized properly. The customer is spending more reasonably for what they're going to get, and they can have the confidence that even a few years out that array is going to support that load. Okay. Where do we get these? So for the vendors, oftentimes it's dog food. When they're running their own applications in-house, we can take a model from that and use that information to generate the workload that we're going to run. For the IT customers, it's typically coming out of that current environment. We're trying to get to realism. We're not there yet. No one can have your application, what your application is, translated into a storage testing environment. We're still using, PCAPs are just too darn big today. We need a way to reduce that data to be able to have a data set that's effective that we can then run and use against an array. So watch this space. We're doing a lot of research and work on that today to make that easier to accomplish. But we want to make sure that we can test without having to go to that level, but still have a workload that is accurate. So we typically use a statistical model, where the overall patterns are going to match what you see running in an array for an application in the wild. It also lets us get longer duration, and we don't have to worry about people, companies. I can't imagine a bank giving out PCAPs, with all that security information and customer info. It just isn't going to happen. So we found a better way to do that. Okay. So the process for modeling one of these workloads to be able to test them is to acquire and analyze historical production data from any number of sources. I'll talk about those again in a moment. And from that, create a workload emulation, and then connect that to a storage environment, a lab environment. We don't run these against data centers that are running live. I had one customer one time say, oh no, when things are going wrong, we just want to get that workload and stick it into our production network. And boy, somebody was not quite clear on that concept. So this is all to be done in the lab so that you make effective decisions and run it then, and then you know what you can do in production. And then what we do, we analyze after we run the tests, find the performance limits, compare latency, throughput, IOPS. Those are the key performance indicators we want to test for. Do this against multiple versions of a vendor's array, or in a bake-off situation with multiple vendors to help people make better decisions. So where do we get this stuff? Wire data from taps. We happen to sell one of these, so we love it when people want to use that. They're not everywhere. They're not widely deployed as well. They're, can be costly to put in, but they provide great data. Because we're measuring on the wire, we can probably get the best time resolution, and we'll get the most accurate representation of the commands that run during a particular time. More often, we're getting information from storage array performance tools. Now, these vary really, really widely. Some are going to give you information over a 5-minute interval. Well, in that 5-minute interval, you could have had hundreds of spikes that actually slowed down the array, that was filling up queues in the network or filling up buffers and causing stress on that. And when you take that and average out over 5 minutes, you don't see it. It's just that was 100 IOPS over that 5-minute period, which is not going to tell you very much and give you false, confidence probably in what's going on. But some of these storage array performance tools are getting very good. We've got a couple of vendors we're working with where they're getting down to microsecond level, being able to identify a command, what that command was, how long it ran, and how long it took. And we can take that information and put it back in and run it through the load generation tool to help recreate that app. We can also go from traces. Part of that is watch this space. We're working on that. We generally shy away from it. I know some people are doing this with VD Bench, where they run traces that are generally pretty short duration, because if you're running at 10 gig, that's going to take up a lot of space in a very small time. But it's another source. And last, what a whole lot of people do, well, we think it's going to be about this. Let's just run that and see what it gives us. We do have that capability in our products as well. It's kind of a generic, here's sort of what maybe an Oracle workload would look like, but it's, as I said, it's a guesstimate. So that's where we get the information. Oh, I just went through all this. So taps give you direct access to the application, can be very detailed. There's few security concerns because that data, that proprietary data, just isn't collected. It's not even looked at. Disadvantage, you may need a little finer grained timing than we can get from the taps today. We're on a frontier now. We're trying to get the data in and get it in at the finest resolution possible is the goal. And our technology is slowly rising to where we can do that better. Perf tools, yeah, sometimes you can get data for one application. Now, some performance processes in arrays will only give you aggregate data across the array. Some will give you down to a port or down to get to a port number where you can get specific application information. So again, few security concerns because you're generating the load based upon what the array reports, and it's not reporting as much of that sensitive data. The resolution varies highly. It's not always public. Some vendors are happy to share, some are not. We have had a real tough time trying to say, oh, hey, can you help us massage this data? No, we don't want to talk to you. Well, they don't want to go through the bake-off. So we have to find another means to do that, and we work to do that as well. Perf tool may summarize across many applications. It also may have very coarse resolution. 5 minutes is not that helpful. A minute is not great. Getting down to a second Now it's getting better. And one of the characteristics of our load generation device is that we don't send steady state. Even if we have 100 IOPS over a second, we'll break that second up and do a series of micro bursts to make sure that it's acting more like what a real array is going to see. Traces, yeah, highly specific, highly accurate. Short duration is the worst part of them, but it can be really difficult to pinpoint if you're trying to solve a problem where in that trace something happened. And there's tools to help people and scripts to help people look through that, but it can still be awfully difficult. And much greater security concerns because you're seeing the trace data. Okay, the guesstimates, very simple to set up, but it's not reflective really of any application. So it's sort of kind of like an app, and you can run with those, but it's not going to give you anywhere near the detailed information to replicate what's happening with an application in a data center. So this is an example of the stuff that gets dumped out. It's typically a CSV file. We take those CSV files and then we manipulate them so that we can get a workload model that's effective out of it. So there's the raw stuff. We do something that's called clustering. It's often the case you'll have a few LUNs, in this case I'll talk about block, a few LUNs that are doing a significant part of the load, maybe 25, 50%, and then it drops off very quickly, and most of the LUNs are getting very little traffic. But by understanding clustering, we can take and combine those high load and lower load LUNs and put them together in a way that makes sense and is realistic for the test. Uniform load across multiple LUNs is not the way to go about it. I'm going to talk about that in just a minute. You're going to overtax the array. You're going to be overstating the load from a bunch of LUNs and understating it or just averaging it out for those few LUNs.
Sometimes applications are like that.
Yeah.
You know, you have a bunch of LUNs and the customer is running an application.
Yep.
That tax 2 LUNs more than the rest of the
It's very
40
common.
LUNs that we have.
Yes, that's what we're saying. We're in violent agreement. So what we're going to do with clustering is to find a way to synthetically match what that varying load is across the LUNs. So here's an example of something we were experimenting. We've been at this for 9 years now, and we've been learning a lot. And early on, later on we did a whole lot better than we were early on, because modeling applications is taking a lot of time. So we took one workload and tried to spread that across hundreds of LUNs. So now instead of those couple LUNs that are really busy, we're trying to do that across all of them. And it horribly overstated stuff. We were seeing, latency is the typical measurement for it. We were saying 130 milliseconds latency. No, not very many people are going to accept that. So we looked at clustering. We looked at the way of distributing these different types of workloads across the LUNs, and then ran these tests. So we saw that latency dropped down to under 4 milliseconds, the throughput and IOPS jumped, and it was a much more accurate and true way of measuring it. So we want to choose a limited number of example workloads as the input. We'll take those big ones and use them very accurately. For those ones that are just getting a very small amount of work, we'll pick some examples from those and then replicate them across the number of LUNs that need to be tested. This can be hundreds, of course, it can be a large number. And we'll produce the model from this cluster that we create. So here's an example of that. We see that there is just a couple LUNs doing a whole lot of work and many doing lower levels of work. So we just took that idea and from that we typically will create 8 to 10 different workloads and then balance them across all of the LUNs in the test. We'll do a percentage of the high traffic LUNs and a percentage of the low traffic LUNs that average out and gets us a good result. So the way we do this, we get a CSV file from a customer, and we then import that CSV file into our application. Drop it in. We then parse that file, examine it. That's our software. We've got a we've got a few data scientists that are pretty sharp that have come up with ways to take that and convert that CSV file into a test that we do internally. So we go through that, we look at the results of that import, see if that accurately reflects what the customer is seeing from their own performance statistics and what they're running. And then we run that test based upon that. There's more I could show you here, and we'd love to talk to you. It's a longer conversation than I can do in an hour. But the idea is we are representing that workload in a way that matches within 1 to 4% of what we really saw in production. So it's close. We'll get better as time goes by. We're doing a lot of work on it every week. And this is based upon, a lot of this is based upon work that we've done in our own professional services group. We've got guys out every week going and working with customers, building the workload, running it, helping them with sizing an array, helping them with doing a bake-off, helping vendors to make sure that they're doing tests that make sense. A lot of time we'll take the vendor's performance stats that they don't publish when they're having a customer problem and take that in and recreate that so that we can recreate that problem pretty closely. We have something that you can go up on the web and see. www.workloadcentral.com is a free service. You can take a CSV file like I've been talking about, upload it, and it'll give you a view of that application. Now this is similar to what we do. It's not exactly the same, and what you get out of it is not something that you can run on other products, but you can get a pretty good view of what that application was doing. So you upload it to the web. It's a CSV file. You can view the results from that after it goes through and does the processing. It'll tell you a lot of information. We see that we get the KPIs, throughput, IOPS, latency. It'll note if there were errors. It'll give command mix distribution. This is obviously a little bit more important and interesting if you're doing file than block. But so we can break out the metadata. We can break out the reads, writes, and show what the performance looked like over time. The results of those tests also can be converted and run with our load generation platform. So this was, what I've shown you here was designed for work with our tools, obviously. I just got a few things comments that I think are worth talking about. So when you're testing using a test harness that's using VMs, number one, make sure you've got the same OS version, same system, same drivers. Everything is alike as you can possibly get, and realize that if you make that test, you run it in that particular environment, it's not necessarily transportable anywhere else unless that other data center or that other test lab has the exact same conditions. Your results will vary. Especially is important when you're comparing multiple systems. You want to make sure that you're testing apples for apples. Enable bursts. It's not always an easy thing to do, but it's important to do. I think I've got it on the next slide, but I'll say it here anyway. Make sure that the OS supports bursts and is turned on. Make sure the hypervisor supports them and they're turned on. And make sure that the HBAs support them and they're turned on. Otherwise, everything gets lost and it ends up being a steady state workload. So it's really important to have those components in the same way. That's what I said here. Ensure that the test OS, hypervisor, HBA drivers all support manipulating the QDepth and set the same. One thing that we do after we generate a workload and run it, we'll take it and try running that workload and varying the QDepth so that we find the best performance for that application. We've been surprised to learn that often lower QDepths give overall better performance because less gets stuck in the network. And then we say to test with multiple profiles to accurately represent the application. That means testing on different times in the business cycle, testing with the enterprise features, testing with the periodic processing. Now, we realize that customers aren't going to take 6 months to do a performance evaluation to try to get through a few arrays. So instead, we come up with what looks like it's going to be a rainy day, something where things are not going so great, and then combining things, the other enterprise features and the periodic processing to look realistic. As applications are being combined on an array, you say, oh, we want to test all the peak periods for each of those applications. Well, maybe you don't, because they might be happening totally different times of the day, different times of the business cycle. So you just want to make sure that when you're doing your baselining and understanding it, that you get that, you take those things into consideration and make sure that what you're running is realistic. And gosh, I'm getting through this faster than I thought I would today. So, this process lets you upload different profiles, whatever you need to run, that get that fingerprint of that particular application that's going to go in that particular data center, and run that one rather than doing something that's guessing. I spoke a lot about this on Monday. You know, uniform random write workloads are probably not very helpful because there's darn few applications that write uniformly randomly and don't ever read anything back and are going at a constant rate. That is something that is often used as a way of showing off the architecture of a particular array rather than anything that you'll see in production. The closer you can get to an application, the more realistic view you're going to have of how that array is going to take care of you over time. Yeah, so as I said, not only we do this for bake-offs, we do this for regression all the time. We have a couple of very large customers that you would recognize that will not put anything into production until they've done testing using our load generation tools, because the worst thing in the world is a regression. Well, the worst thing in the world is an outage, and regression can lead to outage. So they'll do that, and it's not just the storage array software, not just the firmware for that. Test with the network. Anything that is, if there's a bump on the wire, if there's a network component, anything in there, you want to make sure that when that goes in, you do maybe you have an outage and you do everything, upgrade it, and move on, that performance stays afterwards. So that's what I have for you today. Questions?
I got a couple of questions.
Sure.
Typically, at what stage does your company get involved with the vendor? Is it after they complete the regression cycle or complete the test of the ready to release, or somewhere in between?
We, with most of the major vendors, we're in the dev lab and the QA lab, both. So for unit testing and then for perf testing and things like that, we're in there early. Are we at the various early stages? No, because we don't build products for technology that is just emerging, because we're a business, right? And I can say this, we spent quite a bit of money testing FCOE, and we released a product, and it just sat there. So we are careful about those concerns, but we try to get to things as quickly as we can. For Fiber Channel, for example, we've got a pretty complete command set, everything including VTL, all the regular things that you might be running there. We can do the maintenance commands, swapping things in and out. All of that's there and available to you. So the vendors will use us early on for that and through their testing cycles.
Also used for support.
Yeah.
Applications to recreate problems, and also for customers who want to, or customer-facing sales organizations that want to go
Yeah, exactly.
in their product and work and size and all.
So even after it's out, In fact, this is more and more happening. We do bake-offs quite a bit, and we'll go out and do a bake-off. Well, if the customer, if the vendor is also our customer, and something goes wrong, we can give them a copy of that test that we ran and let them use that. I've known of at least 3 times where it turned out to be there was a bug that was fixed overnight, and they're back into the test the next day. Situations where the SE that was out didn't really understand how to tune the box for its best performance, and we're able to see that, come out with a new configuration the next day, and it really can change these proof of concepts overnight.
Besides tuning and reconfiguration, okay, that you recommend to your vendor, what type of defect do you see? Corner cases issues? Do you see hardware issues? Do you see functional firmware issues?
Yes. Yes. Our first sale was a flow issue that didn't show. It was a race condition that didn't show up except under heavy load, and their test harness just wasn't large enough to generate that load effectively. And the guy that brought that product in and started testing with it found the bug in like 25 minutes. And it had gone through a couple of release cycles, and he nailed it right there. We'll find, depending how it's tasted, our vendors oftentimes are using more performance profiling, so the corners types of testing. It's changing now that they'll keep these tests that we get from customers are gold. This is something that was actually out. It was running in a data center, and they're able to take that back. Not only for their ongoing testing, their regressions or whatever they might be testing, perf testing, things like that, but also with the problems that we find. A lot of times customers will have our product in their labs. They use their own performance statistics to grab a condition where customers having an issue, send that back in, and they're able to run that test in the lab and find out what was causing it. Sure. Hi.
Do you have the ability to integrate for your performance profiling?
Mm-hmm.
It showed some visualizations of the results over time. Is there a way to integrate? You're getting all those stats from your applied to your test
Yes.
perspective. Is there a way to integrate that to collect performance counters and other diagnostic information from the storage that you're measuring, so you could sort of interleave those for analysis?
Great question, and the answer is sort of. You have to build it into your own harness because we run storage commands. That's what we're doing. We're looking at the wire. That's our job. But all of what we do can be scripted, and in that harness, we can be running a test, and if a condition is met, we can fire off a note to self, and that could be used to, for example, trigger a Python script that would allow somebody to go look in the array to see what they noted at that same time. So it's a matter of imagination, how well you can define those kinds of conditions. But because everything is automated, we can automate all of our tests. We have our GUIs, but you can run it all in automation. We support Perl and Python and an ability to do runner scripts that will take an example of one of our tests and then convert it into the script, and then that can be run externally to our GUIs. Now, the advantage of running it within the GUI is that we have trending and nice results in trending and all that stuff, and they're viewable in HTML, so even a manager can go out and get something and say, here's this week's results, and look, and we can do regressions over multiple runs and things like that. So there's advantages kind of to do it both ways.
PCAPs.
Yeah, oh yeah. We do take PCAPs. Now, in one port with about 4 gigs of RAM, it's not going to be huge, but we can do rolling buffer PCAPs, or we can do a trace for a certain time period, and that can be viewed as well. Any other questions? Okay, I'm the only thing keeping you away from tonight's party right now.
There's birds of a feather at 5.
Oh, there's birds of a feather, I forgot.
You're not
Sorry.
giving us our beer directly.
No, we're only partially between you and beer. There's at the Good Boss. Thanks, everybody.